Hello and welcome to Ableversity's Python 3 to Cribble tutorial. Today we're going to show you how to send HTTP data to Cribble Stream via Python using Docker for free. Without further ado, let's get started. So you can see the diagram here on the right, what we're going to do. To get there, first we want to do some prerequisites. So very first thing we need to do is completing the tutorial where we created an entire Cribble deployment. It'll take you about 20 minutes. No, it is not a game here that you see in the preview. It is how to add Nginx in front of Cribble and Docker for free. Really what we did was we built an entire distributed environment in this lab, or how to. So you want to complete that first, just so you can take off where we left off. All right. Again, that's the URL there, and I'll throw it in the comments. Now, step one, it's fairly simple. We need to know the difference between Cribble HTTP, or HTTPS, and raw HTTP, or HTTPS, and for that matter, Splunk HEC. They're all technologies for receiving data over HTTP or with TLS certificates. But the difference is the Cribble HTTP is a source that receives data from other Cribble HTTP destinations. So that is Cribble to Cribble HTTP. If you had a Cribble destination, you could set that up to send in, but we're going to use code, so we need to use the raw HTTP, which basically listens on a specific port and captures all the HTTP requests. And let's go ahead and throw these notes in our entire notepad here. So again, the raw HTTP source listens on a specific port, captures all the HTTP requests on that port, and creates a corresponding event that it pushes to its configured event breakers. For the Cribble HTTP, it's really meant to be a destination. All right, so it's a source, yes, but if you configure a destination in your same Cribble deployment, then it'll allow you to send data out to a Cribble HTTP endpoint. Okay, and receive it here. Hope I explained that well enough. It's for Cribble to Cribble HTTP. How about that? Now the Splunk HEC is obviously for Splunk agents to send data in. The Splunk HEC protocol is the protocol itself isn't necessarily unique, but the format of the package, etc., looks a little different than data. And you may have previously configured Splunk HEC endpoints. You could use Cribble Stream Splunk HEC endpoints to replace those if you wanted to. And you'd have to put in the same authentication tokens on the Cribble side, and we'll talk about that a little bit later, but just know what we want to do in today's tutorial is the raw HTTPS. Okay. If you look at the notes for Splunk HEC, it just says it supports receiving data from Splunk on HEC endpoints. Step two, let's go ahead and make sure that Docker is running. Now there's multiple ways to do this. One of my favorites is command line, or Docker desktop is another way to do it. So I'll show you the command line and what it looks like in Docker desktop. So if you don't get anything in the step, then you probably haven't completed the prerequisite. I need you to go back to step 0 and make sure that's done. And there you'll make sure Docker's up and running and whatnot and have the environment built. So when you do these commands, Docker PS, or if you go look at Docker desktop, you should see what we're about to see here. So Docker PS shows me all the running containers. I can see the names of the containers, how long they've been up, when they were created, what image was used, container ID, and the ports they're using. It's kind of jumbled together because my screen's only so wide and it's a lot of data they're trying to show me here. But nevertheless, it's a great way to do it, Docker PS. The other method is using the Docker desktop. Here we can see we're up and running. That's the previous environment we built. Cribble with Nginx it's called. And all the instances, they're up and running. We'll move on to step 3 now. I'm going to add the HTTP data source in Cribble Stream. So first we want to log into Cribble Stream if we haven't done that yet. We'll go to Manage, Worker Groups, Data, Sources, Raw HTTP, and we'll enable it. Show you exactly what that looks like here. I've already logged in, so it's not going to ask me to log in again. I'm going to click on Manage here next to Stream, since I'm in a distributed environment. I go to my default worker group, Data, Sources, type in HTTP just to narrow down the list real quick, and then click on Raw HTTP. Now we can see there's one there already. You may have to create one and name it Test, whatever you want to do there for the name, doesn't matter, but make sure you note there are auth tokens, and if it's empty, you're allowing unauthorized access. So basically, anyone can send to this endpoint if you follow this tutorial to a T. And then another thing to note is the port. So we're on 180 or 10,080. Now, when that is saved, right, I still have to commit it and deploy it to my workers. It's kind of just running in memory on the manager now, or the leader. I need to push it out. So we'll have to commit and we'll have to deploy. As part of the commit, I'll need to put a message. So I'll type out enabling HTTP or raw HTTP. The IP address I'm opening it on, which is all of them. 0.0.0.0 is really the slang for, or code word for all IP addresses on this machine. And then we'll put the port number there too. We'll have to wait a little while for this to allow me to commit. So now's a good time to pause, take a break, come back, or just skip forward a little bit. It takes about 30 seconds for this to complete. Maybe longer than 30 seconds. Appreciate your patience. We're almost ready to commit and deploy. Mileage may vary here in terms of how long it takes you to do it. My hunch is it's the virtual environment in my local machine that's causing this. I got a lot of work going on. And it just takes a long time for me to commit and deploy. But if we had proper resources, this would be real quick. So hopefully this doesn't affect you in your environment like it affects me in mine. If you're following along on a low power machine, you may even have to wait longer for this commit and deploy. When that's done, we'll log into the Ubuntu instance we created. Again, that was in the prerequisite step 4 where that instance was created. So if you don't have an Ubuntu instance, you need to go back to the original step 0 and complete that. And basically, we should be able to log into it with docker exec interactive command here, or the -it switch and bash. I'll show you that real quick. Copy that out. We'll throw that into command prompt. That should get me logged into the Ubuntu instance we have. And it sure did. Worked great. So if you don't get that step right, if you don't get the same output, then you may want to go check the spelling. Make sure you named it correctly. You may have added an S plural or things like that, etc. You may have changed the naming, but we're done with that, and it's up and running. We're logged in. We should be able to download and install Python3, Python pip 3 as well. In order to do that, we'll want to apt update first to make sure we're getting the correct packages, and you may get an error message if you don't apt update first. So be sure to do that. See, it breezes through that real quick. Right, and then you'll want to apt install Python3 space Python3 -pip. Do a -y just so it doesn't ask me if I'm sure. Because yes, I am sure that's exactly what I want to do. Okay. And once that's done, we can move to step 6, which is we're going to use pip to install Python library called requests. This is one of my favorite Python libraries. I use it all the time for API integrations. And when I ran it here in the demo, I've already satisfied the requirement. Okay, but I'm going to go ahead and uninstall it real quick to show you what it looks like if I hadn't already installed it. This is my mistake here, so my apologies. We'll at least get to show the uninstall in pip, right? Pretty simple. Pip uninstall requests. You have to answer yes. And now I can pip install request again, and you can see the full process for the pip install. What we're really looking for here is successfully installed requests. And you'll notice I've got a warning there about being the root user, so pay attention to that if you're in production. If you're in dev, you don't have to worry so much. All right, so step 7 is we're going to open the live view of the raw HTTP input in Cribble stream. And we're going to do some Python after that that's going to send the data in. So we're going to want to capture or set the capture time to a high number, like 300 seconds, or at least enough time so that we can type out all this Python code we're about to type out. I really think 300 seconds is more than enough time. But you can always restart the capture or restart the live view if you don't get your data in time. Okay, so step 8, I'm actually going to dive into Python3 and we're going to run the commands that will send data. Before we do that, we want to fire up this live view and start capturing the data. Again, we want to capture for 300 seconds or a larger time than what's the default. I'll stop it and change capture settings a little bit, start it again. So now we're capturing for 300 seconds. We'll move on to step 8, which is actually the Python code that will send the data to Cribble. Now, in this case, I'm not going to send it through a load balancer to Cribble. We're just going to post it directly to any one of the workers. So to do that first, we have to go into Python. I'll type that up here in just a minute, but we'll import the request library. We'll create a URL, which will be, or a variable called URL, which will have the value of our endpoint. You'll notice it's workers with an S here. If you followed along before, did exactly what I did. And then colon 10080 for the port number. For data, we're just going to create a sample JSON event that says test with the value of only a test for that field. And then we'll do request.posts. In parens, we'll put URL, comma, data equals data, and verify equals false. Now, the only problem with this is the false needs to be a capital F. So, and before we do that, we actually need to jump into Python3. So, kind of skipped a step there, but I'll make up for it here. Python3. You see now we're in Python. You can tell because we've got the 3 greater than signs on the left-hand side. And we can import requests. No error message, right? We'll type out this URL. Cribble with nginx -workers -1. So that's going to send it to worker 1. I can do -2 the test worker 2. And then we'll create our data, which is this JSON event with a field called test and the value of only a test for that field. Okay, you notice I put that in single quotes for the string and double quotes for the strings within the string. Then we'll do the request. So request.post, parens, URL, comma, data equals data, and verify equals capital F on that false. Okay, if you get a response 200, you've done it right. Update the notes there to put the capital F. And we'll come over and you can see we have data here in the live data view. All right, you can see it came from a user agent Python requests. It was the value of the data was there, and let's see here. I guess that means we're on step 9, which is profit. You've done the needful. Now have been able to send from Python to Cribble. So in step 10, why don't you go ahead and subscribe and share. Ring that bell for me. Let me know you like what we're doing. Leave me a comment if you'd like to see more or learn more, something different. Maybe you've got questions about what we did or you had trouble. Just let me know how I can help. Again, we'll go in here just real fast to show you how this Python works. We can just press up and enter a whole bunch and send a bunch of requests through. So if you previously timed out but typed all that code, have no fear, just press up and enter. Anyways, that's what we built right there, Ubuntu TCP 10080 to the Cribble workers. Thanks for watching.